So we're going to be looking at iterations and fixed points today. So when we iterate a function, we are using the recursion process. So if you think about writing a recursive sequence, in order to follow a recursive sequence, I have to know the previous input in order to calculate the next number of the sequence. So we use the same idea with function iteration, and that my previous output becomes the new input. So with this function, 3 times 2 is 6, 6 plus 1 is 7. That output then becomes the next number that I'm going to input into that function. So 3 times 7 is 21. 21 plus 1 is going to give us 22. 22 then becomes our new input. 22 times 3 is 66. 66 plus 1 would give us 67. And then we just keep creating this table and finding new outputs that would then become the next input. So that's really all that we have to think about for function iteration when we're just using the function rule. Now if I'm going to iterate a function graphically, again, we're going to use this line y equals x because that is where inputs and outputs are the same, and that's what we use when we have function iteration. My outputs become the new input. So we pick a point where we're going to start on the x-axis for function iteration. So we're starting here at 10. So we move up that line until I hit the graph of the function. That is the output, which in this case is 7. So 7 now becomes the new input. So because this line over here is going to graph the point 7, 7, again, where those two things are the same, I'm going to move over to that line so that becomes the new input, the new x value that I'm using until I move down and touch that line to get the new output. From that output, I move back over to the line to get to the new input, and then I keep moving down in that direction. So this is a stair-step graph. So we'll look at another one that's going to create a different shape in just a second. But we have a stair-step or a staircase function iteration for that line. So a fixed point is that line that this graph was moving towards. If we go back to this page, you see these stair steps get a lot smaller and a lot closer to this point, and then we're going to get stuck at this intersection point within those two lines because I don't have anywhere else to move to. And so that's what we call a fixed point. So the graph is moving towards that value as we follow this idea of inputs and outputs. So the fixed point for the previous graph would have been at 4. The other thing that we can think about with these are some algebraic calculations. And so to calculate for a fixed point algebraically, this is where the function is going to be equal to x, where my inputs are equal to the outputs. So for a, we saw that previous fixed point was at 4, so I would take the function rule, 0.5x plus 2, set it equal to x, because that's where y is going to be equal to x. I can subtract a half from both sides, so 2 is going to be equal to 0.5x. I would divide both sides by a half, so 2 divided by a half is going to be equal to 4, and there's your fixed point. So for b, to find that fixed point, again, I use the same process that I want to know where this function has inputs equal to its outputs, which is going to be when that function rule is equal to x. I can add 0.7 to both sides, or 0.7x to both sides, so 6 is equal to 1.7x. I would divide both sides by 1.7, and then whatever that decimal is going to be where that fixed point is for that function. Now this line has a negative value, and so when you start to try to find the fixed point graphically through iteration, you're not going to see that nice stair step. We have some other patterns. We have cobwebs, so we can still have an attracting fixed point, but the pattern is not a stair step. It looks like kind of a spiral moving towards the center. We have repelling fixed points, which means that you're moving away from the value when you're iterating. So repelling fixed points are going to occur when your slope is negative in a linear function. Attracting fixed points are going to occur when the slope is positive. Okay. And then you can have a cycle of numbers. So a cycle is a set of numbers. So you can have 2 cycles, 3 cycles, 4 cycles. So basically it's when the same value starts to repeat over and over again. So it might cycle between 1 and -1. It might cycle between 3 decimals. But again, we should see those values repeated constantly in that function iteration.